Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard to 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So till now I was actually teaching the 8th chapter of 9th standard science subject, that was on force and laws of motion. So before that I was teaching the motion chapter, where I have explained different things which are involved in the chapter motion, and also in Newton's laws of motion I have discussed all three laws which are associated with the motion of a particular object or a body. So in this particular chapter you will be mainly learning on a particular force, that is on gravitational force. So now the name of this chapter is gravitation. So what do you mean by gravitation? So every object in this universe has mass, means they have certain tendency to pull other objects towards them. So this particular weak force which a particular massed object exhibits can be known as gravitational force. So for example, if there are two objects lying in a particular universe, then let's say the first object is A and the second object is B. So a small weaker force is acted upon B by A, and a small weaker force will be acted by B upon A and A upon B. So here both the objects which are having certain mass, so for example if mass of A is m1 and mass of B is m2, then both of these objects have certain amount of pull force which is able to pull the other object towards them. So this particular force can be known as gravitational force. But before going in deeper into the gravitational force, how did this gravitational force was discovered? And Newton first time discovered this particular gravitational force when he was sitting under an apple tree. So you all know a famous story of Newton. On earth there was an tree, apple tree, and under this apple tree Newton was resting. So when Newton was resting under this particular apple tree, an apple fall on his head. So when this particular fruit was detached from the tree, why didn't it go up, or why didn't it stay there itself? Why exactly that particular apple fell down towards earth? So by looking at this particular incident, Newton had questions in his mind. So here one thing what Newton noticed was, if this is the earth's surface, this particular apple directly fell on this particular earth in a straight line. So that means without any deviation, this particular apple is moving towards the earth's surface. Force which is responsible for this apple to come to the earth's surface is given by earth. That means here earth is pulling this particular apple. Once the apple is detached from the tree, earth is pulling that particular apple towards its surface. Basically here earth's gravitational force is always directed towards the center of the earth. So that means apple was directly attracted by the earth and this particular apple fell down onto the earth. This is one thing what Newton observed. So by seeing this particular phenomena, Newton came up with a word called gravitation, where gravitation is force exerted by a massed object on another object. So that means each and every object which has mass in this particular universe attracts other objects which are there around them. So that means here every massed object has certain amount of weaker force. That force can be known as gravitational force. So now you can ask a question where apple also has certain mass. So if this is apple, this particular apple has certain mass m, and if you consider this as earth's surface, earth is also having certain mass capital M. So now instead of earth attracting this particular apple, since apple is also having certain amount of force because that also has mass, apple could have also attracted earth. So now why didn't apple attracted earth? Why only earth attracted apple? Because here earth's mass is very much larger than the apple's mass. So since earth's mass is very much larger than apple's mass, instead of apple attracting earth, earth itself will attract apple. Now if you consider another example, you can see that moon always revolves around earth and earth always revolves around sun. So here even moon has certain mass m. So let us call this as small m, and earth has certain mass capital M. So now both these objects has certain mass. That means here they should exhibit some amount of gravitational force on each other. So now because Earth's mass is very much larger than the moon's mass, Earth is continuously pulling moon towards its surface. If moon has very much lesser mass than Earth, then why moon is not falling onto the Earth? Because as we noticed, apple, which has very much lesser mass compared to the Earth's mass, it falls onto the Earth's surface. But moon, it is at a certain distance from Earth, but still the Earth's gravitational force is influencing moon. But still moon is not falling onto the Earth. Why this is happening? So now to understand this revolution of a particular planet around a star or a particular natural satellite like moon revolving around Earth. So to understand this particular phenomena, we can take an example. So if a person holds a thread in his hand, and if we just tie this particular thread to a stone like this, and if we just revolve this stone around him like this, so if we just revolve that stone around him like this, then this particular stone will not go away from this person, and also this particular stone will not come towards the person, but rather it will follow a circular path around that particular person. So that means here stone is actually revolving around this particular person, and in each point this particular stone is changing its direction. So in each point this particular stone is changing its direction means at each point this particular stone is getting a certain amount of force to change its direction. Because at this particular point stone was following this direction, and at this particular position stone will be following this particular direction, and at this point stone will be following this particular direction. So at each point stone is changing its direction. That is because the necessary amount of centripetal force is given by this particular person, which will be pulling towards the center like this. So this particular centripetal force will be acting towards the center. That means towards the hands of this particular person. So because of this centripetal force, that stone, using that force, it will be constantly changing its direction. Basically, when moon is revolving around Earth, here moon is trying to fall onto the Earth, but the gravitational force between Earth and moon, which is there, acts as centripetal force, and this particular centripetal force of Earth's gravitational force means here Earth's gravitational force itself is acting as centripetal force in order to keep that moon in a particular orbit. So in that particular orbit, moon will be revolving around Earth, and similarly Earth will be revolving around Sun, because Sun has greater gravitational force compared to Earth's gravitational force. Here also you can see in this particular centripetal force example, here centripetal force is acting to the center of this particular circular orbit. But still stone is not coming towards the person. It is going in that orbit itself. It is revolving around the person, but it is not coming towards the person, because the necessary amount of centripetal force which is acting on that stone is giving that stone that much amount of change in direction in order to remain on that particular orbit. So that's why stone is revolving around that particular person, but that stone doesn't come towards this particular person. So here also Earth's gravitational force is giving necessary amount of centripetal force to that particular moon, and hence moon is maintaining its orbit around the Earth. So now what if this particular force is broken? That means if suddenly Earth stop giving gravitational force to moon, obviously it doesn't happen, because when Earth should not give any gravitational force to moon means Earth should not have any mass. and if there is no mass, then there is no object at all. So it is never possible. But if we assume that this gravitational force was not there, then suddenly if this gravitational force is taken away, then this particular moon will follow a tangential path, because now all this time this particular moon was revolving around the earth in a particular orbit, and while revolving around the earth, suddenly if this force is broken, then this follows the direction which it will be following at that particular point. So for example, if moon is traveling at this particular position, and suddenly if the gravitational force is ceased, then this particular moon will follow this direction, because initially it will be going in that direction. Because of that gravitational force, it will be changing its direction, but whenever that gravitational force is removed, the moon will follow the tangential direction. So just like when person is revolving this particular stone around him like this, suddenly at one particular point if he leaves the thread, that means he has stopped supplying centripetal force. When he stopped supplying centripetal force, whatever direction this particular stone will be traveling, if this person leaves this stone at this position, so whatever direction this stone is moving, in that direction only the stone starts moving. That means it appears to be a tangential line to a circle. The gravitational force of earth will be influencing the path of moon, so that moon will remain close to earth and it will be revolving in an orbit around the earth. And similarly, sun will be exhibiting certain amount of gravitational force on all the planets in order to make sure that planets remain on that particular necessary orbit where they will be revolving around the sun. So after getting a little bit idea on gravitation and gravitational force, now we will move on to the law of gravitation, universal law of gravitation, which was proposed by Newton. So now we will be looking at universal law of gravitation. So if you consider object A and object B, and if you consider m1 and m2 as the mass of these two objects respectively, and if you consider the distance from the center of these objects, so if you consider this as the center of these objects, so distance between the center of these objects, if you consider that as d, then this gravitational force which is acting by both the planets will be directly proportional to the product of their mass. Why? Because whenever you take huge mass, then gravitational force will be huge. So now if either of the mass is greater, then gravitational force will be greater, because mass is greater means more gravitational force that particular object can possess. So, and also it depends on distance, but gravitational force inversely depends on distance, because if a particular object is moving away from another object, then the influence of gravitational force is very less. So when moon is very much far away from earth's surface, earth cannot influence moon, because the distance has increased and gravitational force, the effect of gravitational force reduces upon increasing the distance. That too, it depends on square of the distance, because you are considering gravitational force with respect to both the objects. So, and the distance is common between both the objects, so that's why you are considering square of the distance. So here gravitational force, if you consider that as capital F, then this capital F is directly proportional to the product of masses. So how big the mass is, that much will be the gravitational force, and how far the objects are, that much weaker will be the gravitational force. That means gravitational force is inversely proportional to the square of the distance between both the objects. So now if distance between these two objects is increased by 2 times, then the force, gravitational force, will be reduced by 4 times, because square of 2 is 4, because gravitational force is inversely proportional to the square of the distance. So if distance is increased by 2 times, then gravitational force will be decreased by 4 times. Similarly, if mass is increased, if mass of both the objects or either of the objects is increased, then gravitational force will be more, because gravitational force directly depends on the product of masses of the objects. and here F is inversely proportional or F is directly proportional to the 1 by d square. So either you can tell gravitational force is directly proportional to 1 by d square, or you can tell F is inversely proportional to d square. So now here I have written F is directly proportional to the mass of the objects, and it is directly proportional to 1 by d square, or it is inversely proportional to d square. So based on this, we got F directly proportional to m1 m2 divided by d square. So in order to make this gravitational force equal to this particular term, you should introduce a proportionality constant. So Newton came up with a proportionality constant named G, capital G, m1 m2 divided by d square. Here G is the proportionality constant for this particular gravitational force. Now how to calculate what is the proportionality constant? So now in order to calculate the proportionality constant G, you can just bring this d square to LHS, so it will go to the numerator, and m1 m2 to the LHS, it will go to the denominator. So d square divided by m1 m2, and in LHS already the force, gravitational force F is there. So now the proportionality constant G will be equal to force, gravitational force into distance square divided by mass m1 and m2, the product of mass m1 and m2. So in 1731 to 1810, there was a scientist named Henry Cavendish. So there was a scientist named Henry Cavendish. This particular scientist, by using sensitive balance, he did an experiment and found what is the gravitational constant. Since this particular law of gravitation is universal law of gravitation, that means this particular law of gravitation can be applied to any objects in this particular universe. So he calculated the proportionality constant of gravitation, that was equal to 6.673 into 10 power minus 11. So now we should actually notice what might be the SI unit of this particular proportionality constant of gravitation. So here we have force. Force means it is Newton, and we have distance square. So distance is measured in meters, so Newton meter square per. We have 2 mass, so that means kg square. So Newton meter square per kg square, or kg power minus 2 will be the SI unit for this proportionality constant. So now we have an idea about gravitation, we have an idea about gravitational force, and we have also learnt about universal law of gravitation. So the further concepts which are there in this particular chapter, I'll be teaching in my subsequent video. So till then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.